Last lesson of the week then, guys. Like I said at the end of the last lesson, research methods recap. So we need to keep up a bit of revision. It'll still link in with memory though. So as we go through the weeks, do more and more revision, and then if we finish before schedule, which I think we might, we'll get some revision of other topics done as well. Ready for year 2. So what you need to make sure you've got is paper and a pen to write things down on, because it'll be exam questions and then give you the answers. I want you to send me just evidence that you've done this, whether that be a picture or like a mark you've given yourself, how many did you get right, and like a target you need to get better on. And to keep your mind a little bit active, get yourself some water, maybe a bit of chocolate, a little bit of a treat to get you through research methods, because I know how much you will love it. So starter then, just to make sure we're back into memory, I'm going to give you an essay. So strictly speaking, this isn't a full essay question, but it does come into making the majority of the AO1, and it'll definitely help you with next week. So the essay I want you to plan for now is discuss research into coding capacity and duration of short-term memory and long-term memory. Make sure it's detailed, but it shouldn't be too long. And the main thing you need to remember is that it's only 6 marks for AO1, so you need to be quite selective. I'd go for generally 1 piece of research into coding, 1 for capacity, 1 into duration. Mix it up between short-term and long-term. And then in your evaluation, you're going to have to mention the 3 studies that you choose at least once. But remember to do strengths and weaknesses. So time yourself, give yourself 10 minutes or so. See how much you get down, use your booklet if you need to, so you've got a good essay plan there. So just a bit of a recap of that first lesson and of the week, first couple of lessons really of the research. So we'll now go on to our revision bit. So you'll use your phone as a calculator wherever you need to. Time yourself if you want to. I'll tell you to time yourself in places and so on, but try and test yourself out as much as you can. Try and do it without your notes. I'll go through some answers which you can use your booklet for then as well. So I'm going to do research methods, bit of a variety of mainly the things we've done January, February, and just bear with me, let's see how it goes. We need to recap it as much as we can. So scenario, this is going to be the same scenario all the way through all the questions that we're going to answer. So Jason is a university psychology student who is looking at the capacity of short-term memory. He decides to use a similar method to Jacob's in giving participants lists of digits and asking them to recall them to find their maximum capacity. The results are shown below. So 10 participants, the maximum digit span is next to it. So work out the mean, the mode and the median for this data. Pause the video whilst you do it. So what we should have, mean 7.5, mode 9 and a median of 8, hopefully anyway. So that was just our first little bit into research methods, nice and easy. What you need to remember is they're probably not going to call it mean, mode, median in the exam. They're going to say measure of central tendency to throw you off. They'll probably ask you which is the best one. If there's an extreme outlier, it's not going to be the mean, but the mean is usually the one to go for. Just make sure you recap when you use each one and what issues there are with each one as well. Now we're going to use this data. Now we're going to do a SKEW. So you need to briefly draw some axes. I've put the axes here for you so you can give it a go. Try and do it, see how you get on without your notes. What would you go for if they ask you to draw a SKEW or a distribution with the data that you've just got, so the mean, the mode, the median? What would you do? So pause it here, give it a go, let's see how well you can remember it. So let's have a run through, see if yours matches it. If it doesn't, either redo it or just go over it in a different colour pen. So what you need to remember is your mean is always the shortest line, then your median is the middle one, and the mode is always the tallest line. The way to remember it, mode is the most common, so it should have the most amount of line there. So what type of SKEW does this show us? Negative. That's a bit of a squibbly line. It doesn't have to be perfect, so don't try and do it with a ruler or anything like that. That's all the examiner wants, so it's a negative skew. You will be asked in a SKEW type question, what does this mean for the data or the experiment? So you'd have to justify it. It's a negative skew because the mode is higher than the mean, and this suggests that Jason's test was much too easy. So it needs to be made a little more harder to get a true reflection of data. So you might have to interpret the results. This was too hard, this was too easy, and then to change the experiment. So that's what we're going to do. We're going to add more to it. So Jason decides to make it more difficult. He will try doing it with letters instead of numbers. He gets the same 10 participants to complete the experiment. 2 questions for you. A, what experimental design is this and how do you know? And B, give 1 strength and 1 weakness of this experimental design in relation to Jason's experiment. Now it's only a 4-mark question, so you don't need to do full PCs, but you will need to explain in relation to the experiment, so make sure you're mentioning Jason's experiment all the way through. So pause it, time yourself 6-7 minutes. So for A, you should have got it's repeated measures design because the same group of people are participating in 2 conditions. And you need to give 1 strength and 1 weakness of it. So 1 strength is that it's easy and quick to gather the participants for Jason. He only needs 10 instead of 20, so they are readily available for him. A weakness could have a variety of weaknesses. The participants might get bored doing the second condition, so they won't participate fully. There could be some issues in the second task of them knowing what is being expected of them. They might rehearse it more, things like that. But best one to go for is they might get bored or they might be tired, so their memory might not be that great in the second condition. So here is the results. So the digit span and the letters. We're going to move on to statistical tests for this one. So what statistical tests should Jason use to check whether his results are significant or not? Now to get that answer, the 3 questions below will help you. So is he looking for a difference or a relationship? What type of design is being used and what type of data has he gathered? So it's the 3 Ds you will always have to answer in your head to find the stats test. So pause this while you have a think about those 3 questions and answer them. So answers to the questions then. Jason is looking for a difference between the 2 conditions. For the majority of the time, unless they say they are looking for a relationship or they're doing a correlation, it will be a difference. But he's looking for a difference between digits and letters. It is a repeated measures design, which means it's a related. Remember when we do stats tests, we do related and unrelated design. And then what type of data is interval data because it's a test. So the gap between 1, 2, 3, 4, 5 and 6 digits is exactly the same. There's no decimal places, there's no room for interpretation. It's equal gaps means it's interval data because it's a scientific test. So what test should it be? If you remember the acronym, carrots should come mashed with Swede under roast potatoes, that should help you draw out the table of stats tests. So can you pause it, draw out the table, see what you think? And hopefully now that you've drawn the table, you have followed it with your 3 questions and you should find that it is a related t-test. I know this is quite difficult, it's quite boring to try and revise, to be honest with you, but that's the only way you're going to get it is rehearsal, rehearsal, rehearsal. Stats testing they do ask every single year in some way or another, so it is vital that you know how to work out the table, what conditions it is and things like that. So make sure you do revise this as much as you can. But remember, you don't need, apart from the sign test, to be able to calculate them all. So you wouldn't be asked to do the related sign test, related t-test, sorry, after this. You'd just be asked what test is this and to justify. So you'd go through the answers to the 3 questions on the previous slide. Next one then. Obviously, because I am quite annoying, we're going to reduce the data down to make it into categorized data, nominal. That means we can do the sign test. So when we look at the types of data, you've got nominal, ordinal, interval. Interval is the highest level of data, so that would be the most scientific. You will always be able to reduce it down. So I'd always be able to make interval data into ordinal, make ordinal data into nominal. You can't grade up. So I couldn't make nominal data into interval data because it depends on what type of test it is. You might be able to convert to ordinal-ish, but generally speaking, we only bring it down or reduce it down as much as we can. So how would we do it? We would make it nominal by doing, did they do it better or did they get worse in the second condition? And that's what makes it nominal. So that's what we're going to do a sign test on the data, see if it is significant or not. So first things first, we need to do plus minuses to find your S. So can you have a look at this data? Do your pluses, minuses, equals, and tell me what S is, please. Pause it while you do it. So you should have found 3 pluses, 5 minuses, 2 equals. What does that make our S then? Our S is always the smallest out of the pluses and the minuses. So here, even though 2 is the lowest, that's the equals. We ignore that for now. We're only thinking about the pluses and the minuses here. So our F is 3 as it's the least common value. You need to save your equals so that 2, you need to remember it because we need to do that in a second. So for now, calculated with S is 3. Now we need to find our critical value. So critical value, it does say calculated at the top, that is my mistake. We want to find the critical value. So to do this, you need 3 pieces of information. The N value, which is the number of participants in total, take away the equals. We need to know whether it's a one-tailed or a two-tailed hypothesis, and we need to know what level of probability is being used. So for our N value, 10 participants take away our equals, we get the 8. For the purposes of this experiment, Jason wrote a non-directional hypothesis. So can you decide if that's one-tailed or two-tailed? And there hasn't been a comment made about the level of probability. So what level of probability should you use? So there is your critical values table. Can you pause the video, have a workout of what would your critical value be? So I'm hoping we all got 0. Now how we did that is, if you look at the N value, the first bullet point, N value of 8. So this is where we are going to. So we're just looking at these numbers across. Whether it is a one-tailed or a two-tailed hypothesis. Now, if you look below, for the purposes of this experiment, Jason wrote a non-directional. This makes it a two-tailed test. So we essentially can ignore this at the top. So cross it out, scribble it out, whatever you need to do in the exam if it gives it you. So they're gone. So we're looking at these headings, 0.1, 0.05, 0.02, 0.01. Now it doesn't tell us what level of probability we have to use. So we have to use, or we always use, 0.05. You will always use 0.05 unless they tell you otherwise. So we make these two meet, we get 0. So that's our critical value. So critical value of 0, our calculated value is 3. Does that make it significant or not? I want you to have a pause of the video and I want you to try and write a significance statement for me, please. So significance statement, we have got a framework for this, which I have put on here. So the results are not significant to P of 0.05 as the calculated value of S, and then you put the number in, 3, is greater than the critical value of 0. Therefore, we reject the non-directional hypothesis and accept the null hypothesis. So you need to make sure that you put numbers in there, you put the second sentence in there of what you're going to reject, what you're going to accept. And make sure that if it is significant, S has to be less. So make sure that you remember that because you will be asked to write this statement as well. So that was a very quick recap on research methods. I want you to make sure you're looking over it little and often. It will be on every single paper, and for paper 2 it is 50% of the paper. So make sure you are looking over it frequently. I'll do recaps with you as well like this each week. We'll do some exam questions on it. But this was a very short last lesson of the week, mainly because there's a bank holiday coming up, so I'll give you a little bit of leeway. But I do want you to have a bit of homework and have a little bit to do. So your little bit of homework I want sent to me is a revision summary of research into coding capacity and duration of short-term and long-term memory. Do it on flashcards, as a poster, as a PowerPoint, whatever you want to do. Can you make that? It doesn't have to be long. You could do it all on one sheet if you want to. If you want to do one for short-term, one for long-term, that's fine. If you want to do 3, one for coding, one for capacity, one for duration, but make sure you include the research on there. But can you have those sent in to me as soon as you can today? Do it straight after this, just so it's all done then. Shouldn't take you too long. But I hope you have a nice weekend and keep on revising.